Let's talk about how the Horizen ZK proof verification blockchain is going to work. Horizen Labs has been running this in testnet and has been actively developing it for months. And this is my recommendation for the Horizen DAO to vote and approve on doing all this type of stuff and then figure out a way to pay for it. Okay, so we talked about zero-knowledge proofs being used in ZK rollups. There's a lot of other ways that we can use zero-knowledge proofs. We can use them for selective disclosure. We can use them for verifying computation. There's all sorts of different things that we can enable once we have rapid and cost-effective combinations of zero-knowledge proofs and proof verifications. So let's start by how a DApp, a decentralized app, would use the proof verification system. So here on the bottom in blue is a drawing of the proposed Horizen zero-knowledge proof verification system. The first thing that would come up and that would be up and running is the main chain, and the main chain's purpose is to operate a reliable, decentralized blockchain that has the ability to do proof verifications for many type of different zero-knowledge proof cryptographic sets. The way it's being designed right now is to run on the Substrate blockchain framework. Substrate blockchain's framework is an open source project. It's the same framework that's used to build Polkadot and Kusama. It's the same framework that's used to build parachains, which are essentially side chains on Polkadot. So this is a well-established proof of stake framework. There's ways to bring it up and establish security. There needs to be a token or a coin that is that's used for gas. There needs to be validators to do the proof of stake. And this is all well documented, lots of people developing it, continuous improvement. The nice thing about the Substrate blockchain system is you can bring in modules for different things. It's called pallets there, and then you can add your own custom written modules. And this is what makes it ideal for a proof verification chain, is that we can write these proof verification modules and put them into the main blockchain, and as zero-knowledge proof technology continues to improve, we can keep adding proof verification modules to be able to do proof verifications for any type of system out there. So how would we access and use it? So a DApp front end would do something in conjunction with the Ethereum virtual machine that the DApp runs on. And the communications are done through RPC calls. There's other ways, but we're going to just say they're done through RPC calls, remote procedure calls, and all these chains have a reliable system, RPC servers out there that connect into nodes and validators that have a copy of the blockchain and could pass messages on the blockchain. So something is being done, maybe it's a private vote or something, and a zero-knowledge proof is generated. Now, since a zero-knowledge proof is used to verify a computation, it can be generated anywhere. It doesn't have to be generated on a blockchain. In fact, generating it on a blockchain is kind of inefficient. It should be generated in the front-end application, maybe on some specialty servers, in a shared proving system, or perhaps on some GPUs or ASICs. But anyway, the proof is generated. Now, when the Horizen proof verification chain is running by itself, it's a basic chain. It has basic functions. It does proof verifications. You can send an RPC call with your proof to it, and you'll get an immediate response as to whether the proof is verified or not. Then that verification will be put in the memory pool and put onto the blockchain so that it can be looked at in the block explorer, and you can see that the proof verification was completed. So that's great functionality right there from the very beginning. Now, it'd be great to have even more functionality, because the proof verification doesn't come for free. It needs to be paid for in whatever the base coin of this blockchain is. So this DApp front end needs to have a wallet and be able to pay for that proof generation. And it needs to pay for the proof verification. It needs to pay for the proof verification whether it was a valid proof or not a valid proof. That way the system can't be spammed. So anyway, we get this up and running pretty quick, and we're going to have a good decentralized, reliable blockchain system that's up and running. And Horizen's been running decentralized, reliable blockchain systems, improving them, operating them, maintaining them, dealing with issues since 2017. And in 2023, Horizen launched its own Ethereum virtual machine, Horizen Eon, a proof of stake system that's connected to the existing Horizen main chain through a custom written cross-chain transfer protocol. So Horizen Labs, working with Horizen, has a lot of experience building decentralized, reliable blockchains that use zero-knowledge proofs. So that's why when we're looking at doing proof verification, running our own blockchain is the natural step for Horizen and Horizen Labs team. Okay, so this is a great start. However, we can improve this. So we can improve this system by doing exactly what Polkadot does with its parachains. We can have a parachain that's an Ethereum virtual machine. And it would make sense to call that Eon version 2.0 or something like that. Because the nice thing is, from the substrate relay chain to the parachain, there's a built-in bridge. High speed, very efficient, and to be able to access this type of system in a more complicated way, we need to have an Ethereum virtual machine. Now, Ethereum virtual machines can run on all sorts of different things. One of the Ethereum virtual machines, of course, is Ethereum, but Arbitrum, Optimism, Linnea, they're all versions of Ethereum virtual machines. In fact, people that are building on Bitcoin are building Ethereum virtual machines to interface to the rest of the Web3 ecosystem. Even Avalanche has an Ethereum virtual machine, the C chain, that allows it to interface to the rest of the ecosystem. So it would just make sense that we have an Ethereum virtual machine that would interface to the rest of the ecosystem and enable additional things. Now, when the Ethereum virtual machine, of course, it's a state machine and it does smart contracts. And the way EVMs communicate with each other is through a bridge. And this can be payments, transfers of tokens, it can be message passing, layer 0, Axelar, wormhole. All these are ways of communication between different Ethereum virtual machines. And so I've drawn these out here as ways to get them. And I didn't want to complicate this drawing too much. But if we wanted to take our proof verification to another level by perhaps integrating it into the smart contracts of other EVMs or accepting payments from smart contracts, that is how this Ethereum virtual machine that's linked to the proof verification would work. So one thing that we could do is we could take this coin and make it a token on this EVM. And then that token could be traded on other Ethereum virtual machines, on decentralized exchanges and things like that. Of course, we could connect to an exchange directly from our proof verification chain, but many exchanges like to connect to EVMs. It's simpler and easier for them to do that. Same thing for wallets. They like having EVMs to connect to. So although we're going to have wallets and exchanges and all sorts of different things on our proof verification chain, by having an EVM, it makes a lot of things just work a little bit better in the system. So by working all this way together, we're going to be able to, if everything gets approved in the proposals, all the various caveats, get our proof verification chain up and running and have the native coin for that going, and then we'll be able to take our time, maybe a few months after that, and create an Ethereum virtual machine. There's some really good Polkadot type Ethereum virtual machines out there. Moonbeam comes to mind. They've done a lot of development. So this is something else where we can do what people in the Web3 space do, is they collaborate and they compose and they take work that other people have done and they extend it and then contribute back. So I love working in the Web3 space. But this is basically how the proof verification chain would be able to work immediately with decentralized applications, and then we'll be able to work in a more complex way with the rest of the Web3 ecosystem. Thanks.